folks, Mrs. White here. Today we are going to start practicing all the stuff that we've done. Today we're going to focus on practicing section 5.4, which is graphing square roots. We'll do that in our sit and begin. We're actually going to just do two. And then we're going to practice solving radical equations. So we'll go over the homework that you folks had due last night, which was the 5 solving problems. Then we will look at solving radical equations. I have kind of an activity for you. The link, it says that it's below, but this is unclickable. It is listed in the Google Classroom. And it does involve coloring. The coloring part is not mandatory though. Okay, so keep that in mind as you complete the assignment. So let's start off by reviewing our graphing. I see that these are both square root graphs. So my strategy for that is to make an XY chart. Now, I don't just pick any x's willy-nilly to put here. Instead, I'm going to take my radicand, which is whatever's underneath my root sign, and I'm going to set it equal to the 3 smallest perfect squares that exist. And the 3 smallest perfect squares are 0, 1, and 4. Because 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. And now I'm just going to get my x alone. So I'm going to add 5, divide by 2, divide by 2. I end up with 5 halves as my first x value. My next one, if I add 5, I get 6 here, right? Divide 2, I end up with 3. So that'll be my next x value. And then my final one will be where I add 5, I get 9, and then divide the 9 by 2. I'm going to leave it as 9 halves. So this one's not super fun because I am going to be plugging in some fractions, but when I do that, because I'm timesing by 2 here, things are going to work out really, really nicely. Okay? So let's do that now. We're going to take this 5 halves and we're going to plug it in right here. So we have the square root, or excuse me, negative square root of 2 times 5 over 2. Minus 5. So I'll put this over 1. I get 10 over 2, which is 5. 5 minus 5 is 0. So I technically have the square root, or excuse me, negative square root of 0, which is like negative 0, which is just 0. So I'm going to go over 5 halves, which 5 divided by 2 is 2.5. And I'm going to go up 0. My next point is 3, so I'm going to plug a 3 in right here. So I have 2 times 3 is 6. 6 minus 5 is 1. So I currently have negative square root of 1, right? When we simplified in here, we got 1. So the square root of 1 is 1. Apply the negative, negative 1. So I'm going to go over 3. Oops, that dot, I accidentally put at 3. Let me erase that and fix this. That first dot I said should be at 2.5. I wasn't paying attention to the scale. So 2.5 is actually here. And then for the next point, I'm going to go over 3 and then down to negative 1. So over 3 and then negative 1 would be here since this line is negative 2. The last point I'm going to do, so I can already see it's going upside down, and it's upside down because of that negative on the outside. Okay, that's a reflection. When we multiply by a negative on the inside or outside, we know it's either going to be upside down or backwards. So for 9 over 2, I'll just rewrite the whole shebang since that one's a little bit more complicated. We'll have 2 times 9 over 2. Minus 5, okay, I'd put this over 1. Across the top is 18 over 2. 18 over 2 is the exact same thing as 9, so we have 9 minus 5. So we have negative square root of 4. So the negative stays on the outside. Square root of 4 is 2, so I'm going to go over 4.5. So 4.5 is here, and I'm going to go down to negative 2. And here is my radical. Or excuse me, my square root graph. Now I'll come over and do this one, okay? And hopefully this is just a review and you're like, oh yeah, I remember doing this last week, okay? And that's the whole idea, is that hopefully it is somewhat familiar feeling. I do not know my x's yet, but my strategy is to make a table. I'm going to take just my radicand, x plus 4, and I'm going to set it equal to 0. I'm going to take x plus 4 and I'm going to set it equal to 1. And I'm going to take my x plus 4 and I'm going to set it equal to 4. So I'm going to subtract 4 here, and I get negative 4. I'm going to subtract 4 here, and I get negative 3. And lastly, I'm going to subtract 4 here, and I get 0. So these are going to be the x values that I plug in to get my coordinate pairs. So if I plug a -4 in here, -4 plus 4 is 0. The square root of 0 is 0. 0 minus 2, -2. So I'm going to go over to -4 and down to -2. For my next one, I'm going to plug in -3 right here. So -3 go towards the positives. 4 is +1. The square root of 1 is 1. And 1 minus 2 is -1. So I'm going to go over to -3 and down to -1. My last point has me plugging in 0. So 0 plus 4 is 4. Don't forget, square root of 4 is 2. 2 minus 2 is 0. Right there. I always have to start wherever this first point was that was derived from this 0. So I start at the pink and go up. And there's my curve. Not drawn very well. Okay? Hopefully that's a nice little quick reminder. You can always look back at your homework if you need some more review. When we do the whole chapter review, you'll see a few more of these graphs too for you to be able to practice. So let's take a look at last night's homework. That was due today. There were these 5 problems. What I'm going to do is I'm going to solve each of them quietly, and then I will go over how I got the answer. All right, folks, so for my first one, I got 27 over 2. I did get 54 over 4, but they were both even, so I cut them both in half, and at that point, I couldn't do any more. So I should double check that this works. If I end up with 27 over 2 and I times it by 4 over 1, I'm going to get 54. 54 minus 5 is going to be 49. Square root of 49 is 7. 5 plus 7 is 12, so it does work. Really quickly, I said I have to get my radical alone, so I subtracted 5. After that, it was alone. The invisible index number here is a 2. It's a square root, so I squared both sides, at which point I then got rid of my radical sign, so it was easy. I added 5, divided by 4, and got my fractional answer. Let's take a look at our next one. Our next answer is n equals 19. I got that first by isolating my root again, so I added 6, and then to cancel out a cube root, I raised it to the 3rd power on both sides. So I ended up with n plus 8. 3 cubed is 3 times 3 times 3, or 3 times 3 is 9, 9 times 3 is 27. So then I subtracted 8, and that's where I got the 19. I can double check that this works. 19 plus 8 is 27. The cube root of 27 is 3. 3 minus 6 is -3, so everything there works. Next problem, first one that's an exponential form, okay? You can choose to make this a cube root right now, okay, by going like this. Or you could move the 3 over first and then make it a cube root. It doesn't really matter. And the answer to this one is y equals 2. First things first, if you put it in radical form, it's a cube root. Then you should subtract 3. Then, because it's a cube root, we should raise it to a 3rd power on both sides to cancel it out. And then lastly, divide by 4 to get to our solution. Only 2 left. Let's take a look at the next one. I notice that it has a root on both sides and that the roots are totally alone. There's nothing going on the outside of them. So my first step is going to be to raise it to the 2nd power. And the solution to this one is 9. So if you follow my work, after I squared both sides, I had really just a normal linear equation to handle. So I subtracted my t's onto the same side, and then I added my constants to the same side, and I ended up with 9. I can check this 9 really quickly. 2 times 9 is 18. 18 minus 9 is 11. So over here I have the square root of 11. I can also add 9 here, so put 9 plus 2, and that's automatically 11, so I have square root of 11. It doesn't really matter what that equals, right? Is square root of 11 equal to square root of 11? The answer is yes, it works. Let's take a look at this last problem, and then we'll see what our practice activity is going to be for today and or for your homework. All right, so let's take a look at our last one. I noticed it had a fractional exponent, which let me know that I was going to be dealing with a radical sign, so I put it into radical form versus exponential form. Then I said, all right, that was only attached to this parentheses. I got to get rid of this minus 4 by adding it to each side. Then, since my radical was alone, my cube root was by itself, I was ready to raise that to the third power on both sides. At which point I had x minus 5 equals 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8. And then I'm going to add 5 to get to my 13. I can check this 13 really quick here. So 13 minus 5 is 8. The cube root of 8 is 2. 2 minus 4 is negative 2. It does work. Okay? So hopefully that was enough of a little review to kind of see a little bit of each of these types of exponential or radical problems. Really, they're the exact same, right? If it's a fractional exponent, it is exponential. It is radical. So let's look at what your activity is going to be today. You perhaps already previewed it on Google Classroom. It's 2 sheets. This sheet is not mandatory. It's just like a nerdy way for you to be able to check your stuff, and I'll be able to show you what the key of it looks like, and you'll know if you did it right just based on the colors. It's a color by number, which is kind of fun. So what you'll do is you will solve all of these problems. You will solve all of these problems, and then you'll match them up because they'll have the same answers. So for example, if I solve this one, maybe it matches over to orange. I know for a fact that it doesn't. I know which number matches to orange, but let's say I solved this and I got the answer 5, and I solved this and the answer to this is 5. That means where number 3 is, I'm going to color orange on here. So I'd come over here as a 3, color it orange, orange, orange. This behind these polka dots is all orange. Anywhere that I see the number 3, I would color orange. So I know looking at these right now, you're probably like, oh my God, Mrs. White, like we didn't do fractioning ones. I don't want to do this sheet. Like this is stressful. Why don't we tackle number 3 right now? And we can even tackle number dark green right now. Okay. So we're taking care of 2 of those. The ones that aren't fractions, hopefully you're like, yeah, I can probably do these. I can probably do this. Okay. Our cube root here. Just make sure you're isolating it first. So in this problem, I would have to minus 2 first. In this problem, I have to divide, right? Because it's being multiplied, divide by 4 first. Here I would add by 1, divide by 5, divide by 5. Okay, and again, you won't really know if you're doing them right until you get a matching answer over here. Okay, so maybe just do all of column 1 and then start hitting up column 2. So let's do number 3 right now because I know you're looking at that and you're sweating a little bit. Okay, I don't know what number it is right here. Let me erase my circle. I think it's a 2. Yep. All right, so we'll do number 3. It starts out with a 2 equals 1 plus the square root of 29 minus 4x, and that's a 29. The whole thing is over negative 3. Now, not just the root, not just the 1, right? It's not a little fraction. It is a huge rational expression over here, right? Everything is under negative 3. So what that means is I cannot move this 1 over. I cannot get rid of this root sign until I get rid of this denominator. And that should make you feel better because this symbol right here just means division, right? So this means divide by negative 3. My first step here to get rid of this denominator is to times both sides by negative 3. Because remember, when I times by something I'm dividing by, they both cancel. Okay, and I'm going to have 2 times negative 3 now over here, which is going to be a negative 6, equals, and then when I times by negative 3 here, right, boom, those canceled. And this one gave me my negative 6. So now I'm just going to have 1 plus the square root of 29 minus 4x. Now this looks as easy as the ones above. Okay, don't let that denominator intimidate you. So here you're going to times by 2 and then minus your 17. Okay, who cares that it's a fraction? You're smarter than a fraction. Okay, minus 1, minus 1. Same sign, add and keep. Negative 7 equals the square root of 29 minus 4x. Now hopefully from here you're good to go, right? We're going to square it because it's a square root, right? And we're going to square this side. Well, negative times a negative is a positive, and 7 times 7 is 49, equals, canceling, and I have 29 minus 4x. I'm going to minus 29 minus 29, which gives me 20, equals negative, don't forget that negative is attached to the 4, x, divide by negative 4, divide by negative 4. I get x equals negative 5. So you're welcome. I just did one of your classwork / homeworks for you. Okay. Negative 5. So over here, one of these should have an answer of negative 5. Okay. I'm hoping maybe we don't need to do dark green, right? Maybe I can just hook you up with the first steps, or maybe, you know what, we'll just do dark green, but we're going to shove all our work here without having to put it all underneath, okay? If you can do that on this sheet, fine, but I do need work attached, whether you do it on this sheet or on a separate sheet. I don't need to see the coloring one. If you did do the coloring, I would love to see the coloring brighten up my Google Classroom a little bit. That would make me happy, but I'm not requiring it. So first things first, huge freaking denominator. Get rid of this divide by 2 by timesing by 2. And times by 2. Cancels. I get 20 over here. So I currently have the fourth root of 11x plus 4 plus 17 equals 20. I'm going to minus 17 and minus 17, and I'm going to get 3. So right now I have fourth root of 11x plus 4 equals 3. I'm going to raise it to the fourth, raise it to the fourth. Cancel, cancel. And I have, it's getting nicer and nicer every time, right? 11x plus 4. And then 3 to the fourth I just did earlier, right? 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So I'm going to minus 4, which gives me 77. I'm going to divide by 11, and I get the number 7, okay? I'm feeling like a lot of these answers are going to be pretty reasonable. If there's no solutions, I will leave it to you in the assignment comments on Google Classroom, so you'll know to keep an eye out for it. Again, because I got a 7 here, that means one of these answers should be 7 also, okay? I did not check this, and I did not check the negative 5, but we can check this one really quick. So 7 times 11 is 77. 77 plus 4 is 81. The fourth root of 81 I know is 3. 3 plus 17 is 20. 20 divided by 2 is 10. Yay, it works. Okay, so I'm feeling really good about this 7. If you have questions, folks, please, please, please attend my office hours, okay? Attend my office hours tomorrow. And I'm happy to do any or as many of these as you want in that hour, right? That hour is yours. The people that have attended are the same people every week, which I really appreciate. I know that they get a lot from those office hour times, and I really think that as we move towards reviewing, if you have any questions, now's the time to be attending, and now's the time to definitely be asking. Otherwise, folks, I hope you enjoyed this nice short lesson today, and you enjoy maybe getting a little Zen coloring in going on. I will catch y'all later. Bye.